Hello everyone, I'm Rita. Today I'll present a topic, effect of hypoxia and ocean acidification on the upper thermal-niche boundaries of coral reef fishes. Let's start with the big picture. This graph shows the relationship between the global temperature and carbon dioxide level from 1880 to 2017. A red line is temperature change. It goes up and down but overall increased to 1.1 degree. And the yellow line is carbon dioxide level, which also increased. This suggests a strong link between the greenhouse gases and climate change. As the global warming gets worse, the frequency of ocean acidification and hypoxia are also increasing. Because the climate change led the equator is getting too hot, tropical fish have been moving toward the poles. But ocean acidification and hypoxia make survival even harder. So we want to check 1. The effect of hypoxia and ocean acidification on the upper thermal tolerance of coral reef fishes. 2. Analyze whether the ability to use oxygen is related to the thermal tolerance. Now let's talk about why this topic is important. 1. Climate change had a huge impact on marine ecology. As the ocean conditions change, many species face challenges in their survival. 2. By studying how fish react to different environments, we can better understand their adaptability. This helps us to predict which species might struggle the most in the future. In this study, we used 3 fish species to check it. These 3 types are black axial-cormorants, 5-line cardinal fish, and spiny cormorant stencilfish, respectively. For convenience, we call them the blue fish, the white fish, and the yellow fish. Here's how we did it. The fish were collected near Neeson Island in Australia, and they were kept land in well-oxygenated water at 30 degrees before experiment. And we adjusted the water oxygen tension and the temperature to measure peak rate, PCT max, and CT max, and I will introduce this value later. The important point is only the blue fish was tested under the ocean acidification condition. We use 80 control system to simulate different environments. It's a multifunctional controller for carrion that helps maintain stable water condition. You can use the computer to control a lot of different elements like pH, the temperature, the water level, the light, the protein scanner, or the conductivity. It's a useful system in this study. In this study, we measure 3 things: CT max, peak rate, and the PCT max. The first, I want to introduce the CT max. CT max is critical thermal maximum. It's a high temperature a fish can handle before it loses balance due to body function failure. And I drew a comic to explain it. We can see the fish is happy in the normal temperature water in the first panel. As the temperature rises, the fish feel uncomfortable and struggling. Finally, at the CT max, the fish cannot take the heat anymore and faints. The next is peak rate. Peak rate is critical oxygen tension. It's a lowest oxygen level where a fish can still survive without stress. The fish start in the water with a lot of oxygen. As the oxygen level drops, it starts breathing harder. Finally, it cannot breathe normally and have to use the anaerobic respiration below the peak rate. The last one is PCT max. It means peak critical thermal maximum. It's a high temperature a fish can survive when there is not enough oxygen. PCT max happens when the fish reaches the heat limit at a low oxygen and is connected to the anaerobic transition line. The fish start in the warm water and with enough oxygen. As the temperature rises and the oxygen level drops, the fish starts gasping. Finally, at the PCT max, there isn't enough oxygen and the fish faints. Moreover, we will use water-oxygen tension to observe the movement of the fish. The water-oxygen tension means how much oxygen is in the water. This picture is coming to describe the picret. The red circle is the water-oxygen tension. You can see we adjusted it to measure the picret. This graph is the oxygen level affect the heat tolerance of the bluefish. The x-axis is water-oxygen tension from full of oxygen to no oxygen. And the y-axis is temperature. The red dashed line is the anaerobic transition line. Below this, the fish cannot use oxygen normally and have to use the anaerobic metabolism. First, we focus on the red circle is Ct max. We can see at a high oxygen level, the Ct max stays stable. This point is the Ct max under the 20% oxygen. Compared to this point, the Ct max just dropped a little bit. Pass through the anaerobic transition line, the oxygen level drop and the Ct max also decrease, meaning the fish cannot handle heat as well. Next, we focus on the yellow circle is picret. We can see as the temperature increase, the fish need more oxygen. So we make a simple conclusion. If oxygen level high, the fish can tolerate heat. If oxygen level low, their heat tolerance decrease. This is important because global warming and ocean hypoxia may reduce the survival of coral reef fish. This graph is the oxygen level and the ocean acidification affect the heat tolerance of the bluefish. The red circle is Ct max under the normal condition. The blue circle is Ct max under the ocean acidification condition. The red and blue Ct max curve are similar, meaning ocean acidification does not affect the heat tolerance. Moreover, the PCT max under the acidification condition remains stable, meaning the ocean acidification does not affect their ability to tolerate high temperature. This graph is the oxygen level affect the heat tolerance of two types of fish. Top graph is the whitefish, and the bottom graph is the yellowfish. Their Ct max stays stable at the high oxygen level. At the oxygen level drop, their Ct max decrease. This is the Ct max curve at the bluefish at the 18th page. We can observe the three types of fish, their Ct max curve are similar. So we make a conclusion. 1. Tropical fish can handle high temperature if oxygen is slightly low. 2. Short-term moderate hypoxia and also acidification does not affect their heat tolerance. 3. However, if oxygen drops too much, their heat tolerance will be affected, which could limit their survival and distribution. In summary, moderate hypoxia and the ocean acidification won't directly change where these fish live. Severe hypoxia might impact their ability to adapt. Thank you for your listening.
And I wonder that what is these 2-3 species sample number?
Good question. I forget. Sorry. I don't know.
My question is, I want to know why this paper choose the 3 species to be tested.
I have the same question because the article doesn't mention why they are choosing it, but I guess this region have a lot of 3 types of fish, and there are coral reef fish, and maybe their experience similar in environmental condition. So it's just my opinion, but I don't know why this article will choose the 3 types of fish they didn't mention.
Okay, I got it.
according to your presentation, what is the importance of this study? Because your conclusion is that both acidification or won't affect the fish.
Because the study means you want to know the ocean acidification at Hypatia, because the ocean acidification at Hypatia is the because in this global a lot of region have the serious Hypatia, and the ocean acidification also is the moderate Hypatia, and the ocean acidification do not affect the tropical fish, but serious Hypatia will affect this fish.
Can you explain what is an anaerobic transition line means?
In this region is the pastoral anaerobic transition line. This region there is no oxygen, so the fish have to use the anaerobic metabolism, means anaerobic metabolism, respiration and the metabolism, and then
Yes. Thank you.
So you can see Rita's slides were very colorful. That was really nice. So she found a lot of supporting material from the internet, because the paper she chose was super short. Yes, only 3 pages and with very little figures. So, but unfortunately, you still had 1 minute short. Okay, I will tell you what to do. So she had these very nice, very colorful. So these are all eye catchers. So immediately the audience was brought into her story. However, I think what was missing, I think, let's take a look. You talk about temperature, planet is melting, where fish go, blah. Okay, then you start to talk about the importance. Okay, so what was missing in her introduction slides was because actually in these slides you talk a lot about hypoxia, but you did not tell us the definition. There is actually a definition, and it would be great. Unfortunately, you showed it only in your discussion. I would say these slides deserve to be put into the main talk, where you can tell us, okay, hypoxia is a happening issue, it's urgent, so it should be discussed, not just as acidification, because most people only know about acidification, but hypoxia is equally important. So this one should be brought into the main talk. And additionally, you need to tell us the relationship between oxygen tension and temperature. Because although it's a basic chemistry issue, but many students forget it. You need to tell us why temperature and oxygen tension or oxygen concentration in water is related. You need to tell us that. So that will give you 2 additional slides. Then you can make 10 minutes. All right. And then go to slide 9, where you tell us these are the 3 fish species the author tested, and you use this simple 代号. Sorry, I forgot. So yeah, this is nice. Then here she sort of tell the audience, okay, she has these 3 more complicated terms, and then she said she will introduce them, and later it was really, really nice that she used these hand-drawn, manually drawn cartoons to tell us what are these about. So this is very clear, so that's really nice. And then later on, she did not hesitate to remind us again and again what these terms are about. So these are really, really great. Although I think this can be sort of more simplified. You have where is picrete? Here you only have picrete. Okay. So if I were you, I would probably highlight this, because at the back I have the impression that you have a lot of text here, and because you have too much text, so I didn't read it. So it would be great you just you can color some keywords because you had too much text here. She had only I will take this away. So she had only one figure actually in the paper, and 3 panels in the figure, and she really took time, and she also modified it. I think the original background is of course not black, so she modified it to match her style. So you see, did you redraw it? Yes. Oh, okay. Okay, so that's my impression. So this figure looks different from the paper, but she redraw it and make it really clear. Yes, yeah, make it really clear. That was really nice. And she also used this kind of guideline to help us understand what are these. These are 100% oxygen. And maybe you can tell us what is maybe the definition of hypoxia in oceanography. Put a line somewhere here. And then this is a little bit too small, so maybe you should make it this large and then maybe use larger font. Yes. And then later, after she carefully explained the figure, she gave us this very simple concluding remark to take away. This is also really nice. And the same here, and there's no interaction between ocean acidification and hypoxia. This is very clear message. So I think her figure was all very nicely explained. And later on, her conclusion was the kind of conclusion I appreciate because it is specific enough. Okay, so the conclusion is not something like, oh, we should pay more attention to hypoxia and ocean acidification. No, not like this. It's more specific, telling the audience what the study is really about. Very specific. So that's the conclusion you can learn from her talk. So overall, it's a very nice talk. So let's thank Rita.